All right, here's video 10. Given the area problems, we got dividing a right triangle into unequal areas, and we're just going to find the solve for the missing rise and run. There's 10. We got one more of this substitution type problem, and then we'll get into the subdivision. Take to the solution. First triangle, the unknown is x1, and we're going to do the same substitution we did before. It's exactly what we did before. So the area is 100. So tangent of 28.5 is equal to y over x, and that's what we got there, y over x. So we're going to solve for x. We want to substitute that. So if we solve for y, we get tangent of 28.5 times x is equal to y. It's funny. That is not true right there. So now that's true. So we're going to take that and use y. So 1/2 the 28.5 times x is equal to the area of that triangle. 100 is equal to 100. So let's take both sides, multiply them by 2 and divide by tangent of 28.5. And we get x squared is equal to that, and then get the square root of both sides. You end up with x equals 19.19.256. That is this dimension here. And then substitute that with the x that's up here. And I want to put that there. We substituted it already. And then you end up with tangent of 28.5 times 19.19. Do it here, so let's go. Let's see, tangent of 28.5 times 19.19256, and copy paste that into the calculator. So we can just say, yeah. I think I did tangent to 28.5 is equal to 10 points. So this is 10.421. Then do the same thing here, except we don't really need to do the whole get to the formula part again. Just change the area. So the square root, instead of the area being 100 like it is here, we're just going to change that to 235. And then you'll end up with 29.42. And then same thing here, we did like that, Control C. And we'll end up with 15.975. So that's how you solve for those. Pretty simple, right? Not sure what I had on the tail end of this. If there was some other, oh yeah, so, well, yes, I'm gonna start to explain because that's pretty quick. We're gonna get into the substitution here, and this is where we get into the quadratic equation. So I'm just gonna give you an introduction. But we know how to substitute this, right? This is 28.5, so I'm just using the same angle. So the same substitution, right? And the x is also the same. It doesn't change, right? If you just look at the top half of this triangle, that x is some big old arrows on that thing, huh? Oh, we want to call that x though, don't we? X with some big old arrows. Let's see. So now we have, so that doesn't change, right? So the x here and the x here, they're the same. So the area of this is still tangent to 28.5 times x squared times x, or sorry, 28 times x. Well, so 1/2 tangent to 28.5 x squared, right? That's that's what we've got right here. That's the triangle right here. And then the area of this is 10.421 times x, right? That's our rectangle. And then what we're going to do is we're going to add those together. So we get 1/2 times the tangent of 28.5 times x squared plus 10.421 times x. And that is going to equals 135. This is 135 is the whole area. So what we have now is the makings of a quadratic. So we're going to take this, instead of equals 135, we're going to subtract 135 from both sides. So 1/2 the tangent to 28.5 x squared plus 10.421 x minus 35. And that is the quadratic form, whatever it's called, right? I just recognize it. I took trig once. And fortunately, I took it and was able to recognize this is the solution I'm looking for. So anyways, we get into the solution. So you get 1/2 of tangent of this is equal to 0.275. So let's go tangent of 1/2 tangent of 28.5. To show you what that is, 2715, right? X squared plus 10.421x, or 0.07x, right? Minus 135. So those become A, B, and C to plug into the quadratic equation. So right here we have, that's what x equals, right? And in here you don't need the positive or negative. It's sort of like an equation for a line. It's always going to be positive, so just run the positive number. That may change given some instances, but I haven't run across it. Even if it's going in this direction, you just say minus becomes a negative. It works out, and I'll get into the next ones. I'll show you why it works out, because we're just subtracting that triangle instead of adding the triangle. But it depends on if it's over 90 or not. Yeah, so that it's solvable. But just to mention, this is a plus or minus if you're not familiar with it. You solve it twice for where a parabola intersects the x axis, and it'll do it in 2 locations. So negative b, so this is b right here, 10.421. So negative 10.421 and plus, or the square root of, and then this is the big right here, b squared 10.421 squared minus 4 times a right there times c negative 135, and then those 2 parentheses plus the parenthesis here plus the parentheses on the outside for the whole top line, right, to keep the whole top line together, divided by 2 times a, and a is again 0.271. And then that's the formula. So if you type that in to just copy that here, you'll see compute 10.2289, and that's what you get there. That was our unknown. That's x. And then you can solve for this by just multiplying 10 times 10.2289 8, 9, enter. You would get, that's not true. Tangent 28.5 times 10.2289, enter. Get 5.554. Then that's how you solve that. So now you have the dimensions of this triangle. You can solve the diagonal easy. And that's pretty much an introduction. It's really the whole shebang. We didn't go over too long, about 10 minutes still, so I'm not sure if I had anything else. So yeah, just an introduction to the quadratic equation. And that's video 10. So the next is, putting this quadratic equation to work, or I'm not sure what's the next one. Let's take a look. Yeah, so the next one is, this one I'm putting it on there because I saw it on one of the exams. So it's, they gave the angles here, and then they gave you the area, and then you got to solve for D. But just to show you, remember that's what we're going to do. It's a pretty easy one. I could have maybe spent, yeah, we'll see. I'm going to get to it next, so see you in the next video. Next video is video 11.